Question 5, we're going to use integration by parts to find the integral of ln x all squared. So up the top here in this red box, I've got the formula for integration by parts, and we use integration by parts when we want to take the integral of the product of two functions, and we'll call them u and dv by dx, where u and v are both functions of x. So there's a couple of ways we can approach this problem. In this video, we are going to rewrite our integral as 1 times ln x all squared. So that's a little trick you can do when you want to integrate by parts and it looks like we've only got one function there. So let's just rewrite our integral. Let's write this as 1 times ln x all squared. Okay, so the next part is we want to choose what is going to be our u and what is going to be our dv by dx. So I'm going to take u as equal to ln x all squared, and the reason is, well, one, we can easily take the derivative of this to get our du by dx, and if you think, well, if we took ln x all squared as dv by dx, then for this part in our formula where we have u times v, we'd have to integrate that function ln x all squared, and that's just straight back to where we started. That is the problem we want to solve, so that doesn't help us. So now we've got u is equal to ln x all squared. If we find du by dx, and we can just use the chain rule to do this, so we'll get 2 times ln x, and then times the derivative of the inside, so times the derivative of ln x, which is just 1 over x. So we'll times that by 1 over x. So that's just going to equal 2 times ln x all over x. So then the next part, we want to find v. So if we've got dv by dx equal to 1, so we've got dv by dx is equal to 1, well then we just take the integral of that with respect to x. So that means v is just going to equal the integral of 1, just write dx, which equals x. So now that we've got our u, our v, our du by dx, and our dv by dx, we can just plug these into our formula and solve this problem. So we can plug these into the formula, and then we get the integral of ln x all squared. So there's no need to keep writing the 1 out. So that's going to equal, well, our u times v. So v was x, u is ln x all squared. So I'll write that as x times ln x, and that's all squared, minus the integral of v, which is x, and then du by dx is 2 ln x over x. So 2 ln x over x. And we'll just rewrite that out again and simplify the integral we had on the right hand side. So we just get x ln x all squared minus, and the 2 here is just a constant, so we'll bring that out the front. It's going to be 2 times the integral of, and then these x's will cancel. So we just get 2 times the integral of ln x. So now I need to find this integral of ln x, and to do that we're going to need to integrate by parts again. So we'll use the same trick that we did before. So we'll write our integral as 1 times ln x. So we just write it as 1 times ln x, and then if we let u equal to ln x, then du by dx is going to equal 1 over x, and letting dv by dx equal to 1, and then therefore v is equal to x. So for this part in red that I've written here, we'll just plug these into our formula for integration by parts. So then we're going to get our integral of ln x is going to be equal to u times v. So that is going to be x times ln x minus the integral of v times du by dx. So v was x, du by dx is 1 over x. And just simplifying that, so x over x is equal to 1. So that is going to equal x times ln x minus the integral of 1. So we can just write, take the integral with respect to x, and that is equal to x ln x minus x. Okay, normally we would write the constant of integration, so plus c, but I'll just write the constant of integration right at the end of our problem. So now we know that the integral of ln x is equal to this expression down here that I've highlighted. So now we'll just plug that back into our problem. So now we get the integral of ln x all squared. That is equal to, or x times ln x all squared minus 2 times the integral of ln x, which was that expression we had down the bottom, which I'll just underline there. So now I've got 2 times x ln x minus x, and simplifying that out is going to equal, or x ln x, and that is all squared, minus 2x times ln x, and then minus 2 times minus x is 2x, and then we'll just add our constant of integration. Okay, so that last line, that is our final answer. So the integral of ln x all squared is x times ln x all squared minus 2x times ln x plus 2x plus c.